Okay, so welcome everybody. Very good afternoon. My name is Thorsten Grabs, and I'm a program manager on the Microsoft Azure Data Platform team. In this session today, we're going to cover elastic database patterns for SaaS applications with a focus on Azure. And with me today is Deborah Dove.
Hi, Deborah Dove. Also in the data platform team, focused on SQL database, and been at Microsoft a long time. 18 of my 20 years have been in SQL. That's the space I love. And so Torsten's going to kick it off, and then I'll jump up and join him.
All right. Good. Let's get started. And let me start out by just giving you a sense of what the plan is for this session. So we're going to spend just a few minutes with Azure SQL Database, basically giving you an overview what it is. But then we're going to dive into what are the various different data models, design patterns that you could leverage to build out the data tier for an elastic application. And there are various different design patterns for these multi-tenant or SaaS applications. And we're going to look at them from in terms of requirements around tenant isolation, but also from a resource utilization and density and cost perspective as well. And then think about which ones are preferable in what situations. And then as you basically go deeper into implementing these kind of elastic database applications, you'll run into a number of challenges that you have to put your head around. What I would like to do is to introduce you to those different challenges and then tell you a little bit more about what capabilities we have in the services, in the product, to help you address those challenges. So let's start with the first part, Azure SQL Database. And the place where you typically find it is at the bottom of a typical application architecture in Azure. I'll walk you through this real quick, starting at the top. Essentially, this is the place where your traffic comes in, either through clients that are connecting with their web browsers through Azure Traffic Manager, or through IoT Hub, for instance, with Internet of Things scenarios and devices and sensors that you're tethering up to the cloud. Then you typically find in the middle an app tier where you're using Azure services such as cloud services, web and worker roles, Azure Web Sites, Azure Web Roles to implement the business logic for your application. And then at the bottom, you have the data tier, and depending on the shape and the structure of the data that you want to work with, again, there are various different service offerings. So if you're into document structured data, there's Azure Document DB. If you're more of the Hadoop kind, then there's HD Insight, streaming offerings. So a variety of different services. The one that we're going to focus on today is Azure SQL Database, which is the relational managed database system in Azure. So, and we'll, as we go and talk about the challenges in the last part of the session, you'll find a variance of this picture. So, zooming into Azure SQL Database, the best way to think about it, it's a fully managed SQL database service for you. So you don't have to worry about setting up high availability failover configurations. Each database that you create in Azure SQL DB comes with a 4 nines availability SLA, which means that behind the scenes, we're managing the failover between different replicas, different copies of the database for you, and it's included in the price. Also, it's quite simple to set up geo disaster recovery, geo replication. It's just a few clicks in the portal, and then you can spin up a replica of your database in a different Azure data center if you want to protect yourself or your application against data center outages. It comes with various different flavors of performance and capacity levels that you can work with, and I'll explain those a little bit more. Last point that I want to mention here, it's pretty much compliant or feature compatible with SQL Server 2014 databases. And I say databases specifically. Whatever you can do in the context of a database in SQL Server 2014, that carries over directly to Azure SQL Database. There are other things that you can do with SQL Server on premises if you're working at the instance level, for instance, setting up cross-instance transactions and queries. Those things do not necessarily carry over in a straightforward way to a SQL database. But whatever fits into the context of a single database, that does carry over. I already mentioned that you can create different capacity and resource levels for your databases. This is a brief overview of essentially how you buy and acquire a database in Azure SQL DB. The basic structure is that you have 3 different performance tiers. The basic performance tiers is most applicable for light transactional workloads. The standard tier should fit the bill for most business applications. And then you have the premium tier for the really critical and highly demanding applications. And capacity, resources, and performance is really the main difference between these 3 tiers that you see here. From a functional perspective, we try to make the difference between these editions as small as possible. There are some exceptions to that rule. So for instance, if you're working with in-memory OLTP tables, they don't fit into the memory footprint that we allow for basic. That's the reason why they're currently limited to the higher service tiers in this picture. But pretty much all the other functionality is consistently available across all of them. That's our goal. Good. Also, in terms of the SLA that you get around availability, it's the same across all the different performance tiers that you see here. Then I want to introduce you to another facet of performance and capacity for Azure SQL DB. What you saw on the previous slide essentially is the picture if you create yourself a single database, a singleton database. That singleton database comes with a well-defined allocation of resources and capacity that you can work with. And resources and capacity are the memory that you get that's dedicated to your database, the number of cores or the fractions of cores that is dedicated to your database, but also read and write I/O bandwidth. All of that is governed for you when you get a dedicated quota of these resources for your singleton database. That's great because essentially you come with a guarantee around the capacity, and that makes it very easy for you to plan for very reliable performance. That's a great thing if you have very predictable, very stable workloads, because then you can essentially just look what the demand of the workload is and then provision your capacity exactly to meet that demand. It gets much more challenging if you have a workload where the demand and the capacity requirements fluctuate quite a bit over time for a given database. If you're then provisioning for peak demand, then you're essentially over-provisioning your database for most of the time. And that can become very, very costly because for most of the time, unless you're in one of those peak periods, you have lots of underutilized capacity that you're paying for in that database. And that's a pattern that we actually see quite often in multi-tenant and SaaS applications where you have multiple databases and you allocate different tenants to different databases and you have very different utilization patterns across your tenants. So there's very easy to end up with a lot of over-provisioned databases where you're essentially paying too much money for capacity that you're not using. To address this, we are providing you with what we call elastic database pools, which is a larger capacity allocation, essentially a pool of resources that's guaranteed and that you're paying for. And then you can create yourself as many databases that are sharing that capacity, these resources in the pool as you need for your application. And that gets you out of that place where you're likely to over-provision for single databases because the databases are sharing the resources that you're putting into the pool. We'll talk more about this later. So with that, let me just show you real quick in the portal how you would create yourself a database in SQL DB. You go into the Azure portal. It's really straightforward. Here's SQL database. You give it a name, pick a subscription. You can create or use an existing resource group. You can pick from a data set that should go in there. You need a logical server, which is essentially the logical home where your firewall rules and your logins are created. Here, the pricing tier, this is what we just talked about. Essentially the different performance tiers. Here are the high performance premium tiers that you see in the beginning. You also see the prices for it. And then in blue, this is the standard tier. And at the bottom here in green is the basic tier where you essentially get yourself a SQL Server database for just $5 a month. So that's pretty straightforward. You can pick and choose from these different service tiers. And if at some point you find out that you need more capacity or less capacity for your database, you can dynamically change the service tier for your database as well. The database stays pretty much available through the process where we are reconfiguring the database for the new capacity level that you have chosen. In the worst case, you just have to reopen your connection when we flip over from the old database into the new database. So that really puts you in a position where you can use the elasticity and the cloud to optimize for lower cost for your database. Okay. So jumping back, let's go back in here. Let's talk a little bit more about the different data models, the different architectural patterns that you can leverage to build elastic database applications with a focus on Azure. So if you think about the different application segments that would use database technology in the cloud, we came up with this classification. On the left-hand side, you have ISVs that are going through the transition to become software as a service vendors, plus new software as a service vendors that are emerging in the cloud that don't have an existing SQL Server business. Then in the middle, you have enterprise applications that are customer-facing. And then on the right, you have, again, enterprise applications, but with an inward focus that are essentially catering to the employees of the organization. For this session, we're going to spend most of our time talking about the leftmost pillar that you see here, so the ISVs and the SaaS applications. And the challenge that you typically run into with these kinds of applications is a multi-tenancy. So these applications have to cater for different organizations that are being sold to, and there are oftentimes very stringent requirements around how you treat your tenants and how you treat your tenants' data as well. So in terms of the different concepts that I want to introduce you to, here's a brief overview of those. So you as a SaaS provider would be implementing the application in the cloud. You would host your tenant's data, and then you would sell your application to a customer, which is the tenant, so an organization that consumes your application. And then that organization in turn would bring the end users to the application. What we obviously want to do is we want to design the application in a way so that we can scale it to virtually unlimited numbers of tenants or customers. In many cases, we need to make sure that one tenant cannot see data from another tenant. So tenant isolation requirements are sometimes quite strict, both from a privacy and security perspective, but also from a performance perspective. You want to avoid cases where one of your tenants essentially takes over the system and becomes a noisy neighbor to all of the other tenants that you have in the same application. So that's the unpredictable usage across customers aspect. Now, if you think about essentially that space, you have the tenant isolation requirements as the first dimension on the y-axis in this chart here. And the second dimension then is the sharing of cloud resources across tenants on the x-axis. That gives you this two-dimensional space that you see on the slide here. And you can very simply just divide it up into 4 quadrants and then try to map different design patterns, different architectural patterns for data tiers into that space and start thinking about them. What does it mean and how well do they do from a tenant isolation perspective and from a resource sharing perspective? And resource sharing in this context here really is a proxy for the cost or what my cloud provider bills me. So the more resources I can share among tenants, typically the lower the bill for me as a SaaS provider. And let's start in the lower right-hand corner with lots of resource sharing but little isolation. And the design pattern that you can use here, essentially create yourself a super large database and you pack all of your tenants into that database. And as you add tenants into your application, your data size grows, your database probably needs to grow as well in terms of capacity and resources. And that's great because you can really pack tenants very densely into that single database, and you're only paying for that single database. Tenant isolation, in turn, is a little bit more difficult with that approach because you need to take special precautions to, for instance, make sure that no single tenant becomes a noisy neighbor, takes away resources from the other tenants. Also, if you run into scenarios where you want to do a point-of-time restore for one tenant's data, it's very hard to do that because the only way that you can restore and backup is for the whole database, but not for individual tenants. So a number of these isolation requirements are harder to implement with this shared single large database approach that you see in the lower right-hand corner. So let's work our way up towards the middle of the space that you see here. And that's essentially an approach that oftentimes is called sharding, where you create yourself a number of databases, and then you distribute your tenants' data, for instance, with range partitioning or hash partitioning across the databases that you have. And that gives you a little bit more isolation because obviously you are no longer sharing one single database, but you have a number of tenants allocated to a database, and then another set of tenants goes into the next database. So you have some additional capabilities here where you, for instance, can move tenants from one database to another database to balance resource requirements and capacity and utilization. Now, if you go further up onto the upper left-hand side, we're essentially taking this to an extreme where we're saying each individual tenant gets its own database. And that's what we call the single database per tenant approach, which is great from an isolation perspective because each tenant gets its own database, and you can rely on the database as a container to give you resource isolation. You can secure it separately from other databases. You can do backup and restore for individual databases. So a lot of these isolation requirements that you have to cover for your application just fall into place naturally when you're using this approach. The concern, however, with that is if you're creating lots of these singleton databases with that model, then if tenants are not active all of the time, it's very likely that you're going to over-provision your database capacity by quite a bit because you're essentially provisioning for peak capacity of each of the tenants. The way how we address this is by providing you a set of capabilities that we call the Elastic Database capabilities in Azure SQL DB that help you address these various different challenges. And the first one is essentially using the database per tenant approach that you had on the left-hand side, but giving you the ability to share database resources across tenants when following this approach. And this is what you now see on the right-hand side, the upper right-hand side, database per tenant with elastic pools, where you're creating yourself a pool of capacity that's shared across all of your tenants while following this database per tenant approach. In addition to that, when you use the database per tenant approach, it's quite likely that if you grow your business, you end up with lots of tenants and lots of databases. So the requirements or challenges that you're facing as your business grows is you have to manage and work and develop with more and more databases. So I'll also walk you through a number of capabilities that help you deal with these challenges that are all rooted in the fact that you end up with lots of databases in your data tier. All right, in order to do that, let me show you the demo application that I'll be using for pretty much all of the demos in this session. So it's a kind of a ticket sales application where if you are a theater or a symphony hall, you can onboard into that application and essentially use it to share event schedule with your customers. Jump over here. You can see here is actually a judo club that has events and sells tickets for the event. Here's a third tenant, a jazz club that also has events, and this one didn't come back. And you can buy tickets for it, and we'll bring up a seating chart. It will ask you for a login. You can punch in your credit card number. So it's a kind of semi-functional application. And let me jump over into Visual Studio real quick to show you at least the data tier in the backend. So focus on the left-hand side in Visual Studio into the SQL Server Service Object Explorer. I've opened up the server that hosts all of these databases for the application. And you can see that Contoso Concert Hall, one of the tenants that we saw in the browser, is getting its own database here. You can see some of the other tenants. Let me scroll down. Here's the jazz club that we were just looking at, and here is the judo the Judo Club. And you can see there are about 30 odd tenants that I have created in the application, and they all get their own database in Azure SQL DB. Okay, let's see, just to show you that this more or less works. So here, for Contoso Symphony, here's the seating chart. And as I mentioned, then you can come back and type in your login, and then we'll ask you for your credit card number. So the main takeaway from just essentially looking at this is the demo application. It's this ticket sales application, and the customers for the application are these tenants that we looked at, and each of those tenants is getting its own database in SQL DB. So how does that map further in terms of the architecture behind the scenes? So if you basically zoom into the canonical Azure application model that I showed you in the very first slide, here's how I've instantiated that for this demo application. Essentially, requests are coming in from the top. They're hitting Traffic Manager first, and then they're routed to a cloud service with web and worker roles that are implementing the business logic for the application. And then at the bottom, you have the tenant databases. And if you need to scale the application when onboarding a new tenant into the system, it's quite straightforward. You just create yourself a new database. You put the schema on the database, and then you register that database for the new tenant in a kind of metadata catalog, a customer catalog that you see that's attached to the cloud service. And that catalog database, we'll talk more about it later, that essentially knows what are the tenants that I have in my system and how do these tenants map to the different databases. The first one is the first challenge that I want to introduce you, and the first pattern is something that we already spent some time on. It's essentially, how do I manage capacity if I have lots and lots of databases and lots of tenants with an application scenario like this? And it comes back to what I already mentioned, using elastic database pools instead of singleton databases. And again, the main motivation for that is to share resources across your tenants' databases and to avoid over-provisioning and paying for underutilized database capacity. And pools come in various different flavors. You can create yourself a basic database pool. You can create a standard or a premium database pool. Just as an example, the standard elastic pool gives you up to 400 databases that you can create and that share the capacity for the pool. What's also a quite compelling property of a database, if you put it into a pool, it can stretch across all the various different finer-grained levels of capacity and performance that you find in an individual service tier. So the standard service tier gives you 4 different performance levels. If my database is in an elastic pool, it can elastically fluctuate across the whole spectrum of standard databases. And I don't have to manage that individually. It's built-in functionality. You can create pools like regular databases through the Azure portal, through PowerShell, or through REST APIs. And also through the same set of APIs, you can move databases in and out of pools. So when you move a database out of a pool, it becomes a singleton database. That might be something that's worth thinking about if you know that, for instance, one of your tenants is going to be very, very busy for some time. You can move that tenant out of your pool, give it a dedicated premium database if necessary, and then essentially have the tenant do the work in that dedicated database. And once the tenant is done with the heavy work, then you bring the database back into the pool. Throughout all of these operations, the databases stay online, so there's no loss of availability for you when you're doing these database movements. Also, in terms of monitoring and alerting, it's the same story essentially for both pools and singleton databases. And let me show that for you. So if you remember these 32 databases here that we had for the application, we'll go and find them in just a second in the portal. But first, I want to show you, if you basically started from scratch, you had a logical server in SQL database with a number of databases. And here essentially is, again, a server like the one that we are using in the application, but I'm using standard singleton databases, as you can see if you look into the pricing tier here. Note the little purple ribbon at the top here, which is essentially our workload analytics, giving you a recommendation to consider putting these databases into a pool because it will help save you cost. And that's essentially machine learning technology that we're running behind the scenes over the utilization data that we get from your databases. And based on that, we're making recommendations for you to change service tiers or to put databases in or out of pools. And here, essentially, what the tool has found out is you should create yourself a standard pool, put all 31 databases into it, run the pool at the lowest capacity level because I haven't been utilizing these databases at all. And it also already knows what you're going to save in terms of money. So this will be $240 cheaper as compared to the current setup where we're running singleton standalone databases. And as you basically go in, you can configure the details of the pool. You can decide which individual databases to put into the pool. You can also change the amount of resources and capacity that you put behind all of these databases. And that's essentially the set of dialogues that you see here. Good. I'm not going to click OK. I'm going to jump back into the top level here and bring up an existing pool so they get a sense of how this looks like for the databases that we have just been playing with throughout the demo. And this is my existing pool. If you hit the configure button up here, it will take you to a similar page where you again can change capacity and resource allocation for the pool all up. So if for instance, over time, you add more and more databases, more and more tenants into the pool. You're reaching the capacity limits on the existing pool. You go into the configure experience, and you can increase the amount of capacity that's dedicated to the whole pool. Also, here you see the monitoring surface area in the portal, so you can see what's the overall utilization of the pool. You can also see what are the top databases in terms of resource consumption in the pool in the chart at the bottom. So those are some of the basic things that you would watch as essentially you run your application in production. You can retrieve the same information through DMVs, catalog views, essentially in SQL Server as well, if you want to automate the monitoring. Okay, one more thing that I actually want to show to you as well is, come on. The set of databases that's in the pool. So here you see that list of databases. I just want to show you that the databases that we've worked with, like Contoso Concert Hall, Dogwood Dojo, those are the ones that we saw in the portal that they show up. They are part of the pool. Okay, so this was essentially the first kind of challenge that you're going to run into, managing capacity across a large set of databases. When you're facing that challenge, just remember to think about elastic database pools to make it easier for you, particularly if you have, so some of our largest customers are running in the order of 100,000 databases for their multi-tenant application. You don't want to be micromanaging individual capacity for 100,000 databases. They essentially have put all of these databases into a number of elastic pools. And then if you look at the maximum number of databases in a pool, you still have a large number of pools, but it's 2 orders of magnitude smaller than the number of databases, and then it becomes more tractable. So let's move on to challenge number 2, pattern number 2. You can imagine that if you have lots of databases and you're running a SaaS business, at some point you want to find out some business metrics that tie across tenants in your application. So for instance, things like what are my most profitable tenants, what are my busiest tenants, or which tenants are running out of capacity or space in their databases. All of that are typical reporting aggregation queries that stretch across all these customer databases. Ideally, what you would like to do is use our existing BI or reporting tools that work with SQL Server technology. But what you don't want to do is, if you have lots of databases, connect the tool individually to each of, let's say, the 1,000 or 10,000 databases, run the report on each of the databases, and then manually stitch together the results from the individual databases. What you would rather like to do is have a well-defined connection place, connect your tool that already knows how to use SQL, connect connect that tool to this database, and then leave the heavy lifting to us, essentially have us behind the scenes farm out the query across all of these databases and bring one result back into the tool. And that's the pattern that you see here. Essentially, tools like Power BI, Management Studio, Excel, Tableau, Cognos, Informatica, connecting to a dedicated database that's called Elastic Query here, which then knows about the databases, the customer databases in your data tier, knows how to farm out your query and process it in parallel across all of these databases. And that's a capability that we introduced into Azure SQL Database. It's called Elastic Query. And it follows exactly this pattern. You connect to a single database. As part of the metadata in that single connection point, you register all of the databases in your data tier. And I'll walk you through the setup for it. It's quite straightforward. It's a bunch of DDL statement. This is a one-time setup. Once you've done that, essentially all of the tables that you have that are shared across the data tier, across your tenants, they show up in the connection endpoint so that you get a logical view over your scaled out data tier, and you can start using those tables just like regular SQL Server tables. And that obviously works not just for BI tools that connect to it, but also if you write applications in either T-SQL or through Entity Framework or ADO.NET, they can all leverage these tables that you have in the logical view across your scaled out data tier.
Good question about that.
Yeah.
Who is responsible to set up the database? Is that we or Microsoft? Once I set up all the database channel, and is that automatically will create an elastic query database?
Yeah, so the question, let me repeat the question. So the question is essentially, I created myself my data tier with all of these customer databases. Now, do I automatically get the Elastic Query database, the connection point, or is it something that I have to create and pay for and provision and manage? It's the latter. So you don't automatically get that Elastic Query database. It's a choice for you. If, for whatever reason, you don't need that cross-database reporting capability, then you don't need to create that, and you don't need to pay for that special database. But if you do want to leverage the capability, then you need to create yourself a database like that and go through the DDL steps for it. Now, as opposed to other capabilities that we're going to talk about later in the session, this is the Elastic Query capability is designed for interactive querying across the databases that you have in your multi-tenant data tier. If you're thinking about managing, for instance, the databases because of application changes, rolling out schema changes, park that question. Deborah is going to cover that in just a couple of minutes. Before we go there, let me walk you through a quick demo for Elastic Database Query. And I'll jump back into Visual Studio. Remember, this is our server. These are the databases that we have in the data tier. Over here on the right-hand side, I'm connected already to the Elastic Query database. If you squint, you can see it down here. Elastic Query is the database that I'm connected to, and I've created that database for my data tier. I'll first walk you through a scenario where I use the capability just to do simple lookups into a reference data that I keep in a separate database. That's what I call a vertical partitioning scenario. And the steps are quite similar to the horizontal partitioning one, which I'll cover in just a minute. The first step after you've set up essentially some security aspects like creating a credential that allows you to connect into the remote databases. Once you've done that, the first step is to essentially tell the connection endpoint that I'm connected to right now, what is the remote database that I want to get access to. And you do that by defining an external data source. Here in this simple case where I just want to get access into one single remote database, that the type for that is RDBMS. This is the logical server name for the database. Here's the database name, and this is, as I mentioned, the credential. And I've pre-created all of these external data sources. So here you see the remote reference data source. Once you've set up the external data source, we know that there is a remote database, but we don't know yet which tables you want to get access to. That's the next step. And you do that by creating what we call an external table. And here, in this example, we want to get access to a zip code table, and it lives in that database that's in this external data source that we just created. It's pulling the execution plan right now. I need to turn this off. So, and what you will see is, in hopefully just a second, the external table for zip code.
Once you populate the Elastic Query database, is that when you actually execute queries on the Elastic Query database, are you getting any of the resources back on the Elastic pool resources for individual databases, or is it all now transformed into the Elastic Query database? I assume that's data, Elastic data pool.
Yeah, so essentially the question was, which resources is a query using that's going through Elastic Query? And it depends on the plan shape that we generate for you. What you typically would like to happen is that most of the processing is done in parallel in all of the databases that you have in the pool. And you typically can do that by making sure that you have like joins that you can co-locate, that you do a lot of the grouping and the aggregation, ideally on all of the remote databases. You may then still have residual parts of the query that you can only process at the head node, which is essentially brokering the connections for you. And depending on where that processing happens, it draws the resources from these places. So whatever computation and processing we can push down into, let's say, the shards or the tenant databases, that's drawing from the pool resources, and the residual processing that needs to happen on the head node, that will draw from the capacity that you've dedicated to your connection endpoint. And I'll touch on that again when we look into a query plan. So here you can see those are the three tables, and the zip code is one of them. Once you have gone through that setup, zip code is fairly simple. It's very Redmond-centric. So, and now you see essentially this reference data table, the zip code table, just looks and feels like a regular local table, although all the data lives on a remote database. And you can now start composing with that table. So composing with local and remote tables. The only thing that you need to keep in mind is for everything that's remote, you have a certain cost for actually doing the remote hop. So you will introduce latency as you are pulling data from the remote side. And also there are bandwidth implications. So if you're essentially retrieving hundreds of millions of rows from a remote database for your query, that will take a lot of time. It will take longer as compared to a scenario where the data is available locally. So keep that in mind. Now, the other scenario besides this very simple vertical partitioning scenario is the horizontal partitioning scenario, which caters to this scaled out data tier pattern that we've been working with throughout the session. The way that you define this is very similar to what we just saw. So you use a create external data source statement as, again, to define the scaled out data tier for your database. It's not using the RDBMS type, it's using the sharp map manager type here, which essentially tells the system that the information about the metadata for the data tier, which databases participate and how tenants are mapped to it, is located in this server, in this database. And let me bring this up. And this is this external data source that you see here. And I've created two external tables. The first one is the customer configuration table, which maps to this table that lives in the actual tenant databases. And the schema is identical across all of my tenants, which is quite a typical pattern, but a requirement to use this horizontal partitioning capability. And then I have a second table, external table, which is country, which maps to this guy over on the left in the actual databases. And I've pre-created those, customer configuration country, here they are. And now I can start with a little bit more meaningful queries across my data tier. So for instance, I can run a little report that tells me what different style templates have my tenants opted for. And I can see that theater is popular, symphony is popular, jazz is popular. Can do the same for the country table to see with which countries are my tenants configured to do business, and I can see it's very US-centric at this point. We'll fix that in just a minute. And then down here is a little bit more complex query. It's not necessarily the most meaningful query, but the point that I want to illustrate is that, again, you can compose with horizontally partitioned and vertically partitioned external tables. So here you have the country table, which is horizontally partitioned across all of my tenants. And then you join with the zip code table, which is the remote table in my reference data database. And then I'm doing some grouping and aggregation over the result for that. And you can see this is the result, but what's probably more interesting is to turn on the execution plan for it. And again, the execution plan takes sometimes a little longer to populate. But what you will see essentially is what we just talked about, is how is the query plan split up between things that happen on the remote databases versus processing that needs to happen on my connection endpoint. And the query plan that we're going to look at is going to illustrate this for you. Essentially, there are a number of places in the query plan, usually in the leaves of the tree, where the operation says it's a remote query operation. That indicates that this is going against the remote databases, reference databases, or the scaled out data tier to retrieve the data. It will also show you a SQL statement, and that's the SQL statement that we are sending over to the remote databases to do the processing there. And thinking about the earlier question, so essentially the resources that you will need to pay for on the remote databases is the processing of that SQL statement that you see in this remote query operator. All right, and here is the query plan. So here you see the remote query operator. This goes against the reference data, and you can see down there at the very bottom that this is essentially a SQL statement that goes against the zip code table. Up here is the one that goes against all of the country tables from the different tenants. And then you see the other operations that live on top of these remote query operators, and those are the ones that are run locally, and those are the ones that would go against the capacity and the resources that you have in your connection endpoint. Okay, so with that was our second pattern, and again, the gist of it is I want to do some interactive querying against my scale-out data tier or against a remote database, and that's something that requires a capability in Azure SQL DB that's called Elastic Database Query. With that, I'll hand it over to Deborah, who's going to take you through a few more patterns.
So pattern number 3, thanks for having me up here. Is Elastic Jobs. So as Torsten mentioned, Elastic Query is really about this interactive experience. Elastic Jobs synonymous to SQL Agent for SQL Server, Elastic Jobs for Azure SQL Database. How you can use this to perform lots of operations about management, administration, schema changes, as Torsten mentioned, but also business logic and others. So let's dig in a little. So the key thing here with Elastic Jobs is this capability to define a target group set and then take that one T-SQL and execute that across the entire set as if it's one database. So now you have this scaled out data tier, but you've reduced the complexity of managing that data tier as if it's one database. So let's jump into some of the individual features here and some of the distinguishing aspects and capabilities of Elastic Jobs, which I feel go above and beyond where SQL Agent was, and particularly designed for Azure SQL DB. So as I mentioned, you can use any T-SQL and execute that across all your databases. We've expanded Jobs to now have a very familiar T-SQL interface in addition to REST, PowerShell, and the portal. And here, you'll find the T-SQL language is incredibly familiar to you if you've used SQL Agent before, SP add job step, et cetera. And where we've added some functionality where jobs goes a little further, you'll see that in the language. Another distinguishing factor between the capabilities on SQL with Agent and Elastic Jobs with Azure SQL Database is this built-in retries. So we wanted to design Elastic Jobs specifically for cloud applications, right? And so if you're executing a job and there's any transient failure, as Torsten mentioned earlier with Azure SQL Database as a service, it handles that high availability for you. You're executing that job, you get a transient failure, you don't have to worry about that. Elastic Jobs has customizable retries that allow for automatic retries of that job execution against that individual database. And some of the guarantees that we have with regard to script execution is that any given script will execute at least once against every single database. No script will concurrently execute on top of each other. And so an example of that is, let's say you have a job that runs every 5 minutes. And for whatever reason, one of the databases is taking a little longer. We recognize that, hey, an instance of this job execution is already running against that database. Let's go ahead and skip this round, and we'll pick it up and execute the next scheduled instance of that job. The other thing with Elastic Jobs, so SQL Agent did have this capability of server groups. Now with Azure SQL Database, you're dealing with databases. But we wanted to bring this enhanced functionality so that you could represent your data tier in whatever means to you that data tier represents. And so, for example there, Elastic Jobs enables you to create target group members that are an Elastic pool or multiple Elastic pools. As Torsten mentioned, we have customers that right now have hundreds and hundreds of pools. That is their production environment for all of their tenants. So they define their target group at the Elastic pool levels, and then any new tenant that gets added to an Elastic pool, the next scheduled execution of the job will automatically pick up that database and execute against it. You don't have to go edit your job and redefine that group. You can just define what layer your data tier is, whether it's Elastic pools or servers or multiple servers. We're also going to be adding some of the Azure concepts of Azure, all databases in a subscription, all databases with a tag, or all databases within a resource group. So what's there today is a customer-hosted version of Elastic Jobs. We're in private preview now of an integrated experience of jobs where the agent itself runs just as a feature of the service. And so please contact me if you're interested in jumping into that private preview. And I can get you started. And Torsten's going to jump in here and show a demo on jobs.
Yeah, so thank you. So can you put the mic back on for me? It's not on. Now it is. Yeah. So jumping back into the portal, as Deborah mentioned, Jobs is very tightly integrated with Elastic Pools. And since we have been playing with pools and querying pools all the time, I want to show you a little bit of that. So here is the pool with this ticket application that we've been playing with. You may remember looking at this blade and looking at the resource utilization. And up here, you see a Create Job button and a Manage Jobs button. Obviously, the Create Job would allow you to define a new Elastic database job for the pool, where all of the databases that you have in the pool would execute a T-SQL statement. Let me go into the second part here and Manage Jobs. And And what I would like to do is, you may remember from the earlier demo here, no, not here, almost, from the country query that we've run, which pulled the country configuration information from all of the tenants in my application. We had all of my 32 tenants registered for the United States. I promised that we're going to fix that. And we're going to do this with an Elastic job. And I'll just pick the one, whoops, this guy. The one here, which is a job that I've run previously. The purpose of that job was to essentially just insert new rows for new countries into all my tenant databases. And you can see that I've run it previously, more than a month ago. But here, I'm looking at the piece of T-SQL that implements the job. It's a very simple, very straightforward insert statement into the country configuration table, and it inserts the UK and Germany. And when I click the Run button up here, it will start executing that job against all of the databases that are in the pool. And as essentially the job starts and makes progress, you will see this screen update every couple of seconds. And you can see that the job started, and essentially right now it's in a stage where it figures out what are the databases that I need to run over. So it's figuring out what are the databases in the pool. And then it's spawning individual tasks for each of the databases that I have in the pool. And each task implements the execution of that piece of T-SQL that we looked at against that specific database. And this is where the retries that Deborah mentioned there happen. So you can see that some of the tasks are completed already, others are running. If at any point I see a failure, then the task will tell me it's retrying right now. And then eventually it will complete, and that should be the case right now. So yeah, so the complete job ran through all of the databases. So let's jump back here into the Elastic query and check the result. And you can see now all 32 databases have the new rows for the UK and for Germany. Question?
Where you mentioned, Deborah, the job skip if one of the database jobs ran long. Does the entire job skip? The entire Elastic job? So if you're doing a 5-minute execution, one of the databases takes longer than 5 minutes. Does the entire job skip, or does it just skip for that one?
Right, so the question was around the skipped when it recognizes that a previous instance of that same job execution is running. Does it skip just for that one database, or does it skip the entire job? It skips just that one database. And so we've got a lot of customers that have jobs that run every 5 minutes that are running aggregated business logic, and every once in a while, one of those take just a little longer. The important thing is it just skips that one database, and it'll catch that database second time around. That was a great example of using jobs to deploy reference data across all of your databases. You can imagine the power here of deploying schema, the business logic that I mentioned. I have a tech theater session tomorrow where I'll be showing the newer version of the service and going into some of those monitoring scenarios also. Additional question?
This might be an Elastic job, or it might be a feature of the Elastic tools, but how do the jobs integrate with VSO, and in particular, how do you split apart a database project? So if you have a single schema, I believe like all the list things are here, how best do you integrate a Visual Studio Online, Visual Studio Keep Services now, database project to deploy schemas like that?
So question around deploying schema and how is jobs integrated with projects, Visual Studio TFS projects. So right now with the current preview of jobs, we support T-SQL. And so a fair number of our customers use pure T-SQL scripts to manage the schema across their applications. They write idempotent scripts. They check that into source. They test that with jobs against a set of test databases. Those scripts are deemed golden, and then they can turn around and deploy those scripts with jobs. Another feature that we're looking at integrating with jobs, some folks use the SQL Server data tools, which is the DAC pack and backpack functionality, and that's a feature that we're we're hoping to bring online shortly after public preview, where we integrate in with jobs the capability of you just store that backpack or backpack on a URL, provide the credentials and location of that URL. Jobs would then go grab that. We're prototyping that work right now. Jobs would then go grab that and then deploy it across all of your databases. And it does all of the regular backpack logic, where it does the diffs, what is the schema I need to apply against each database, et cetera.
And would that be in private preview now?
So the backpack functionality will come hopefully right after public preview. So another pattern is about this application building your application and managing, as Torsten mentioned, all of that catalog data and the data distribution and the mapping of those tenants to the databases. And so what we have here is essentially a pattern where, an end user comes in with a login, a tenant ID, into the cloud service. That information is then looked up into the catalog to determine what database do I need to connect to for my information. And then the cloud service then routes that connection to the proper database for that tenant. What we've introduced and has been available for a while is the Elastic Client Library to aid in developing these applications and using the functionality of the library to manage that catalog mapping and the data-dependent routing, the redirection aspects for you. And so here with the client library, you can, while building your application, you can define a shard map manager, a catalog manager, register that new tenant into that map, and then when that tenant connects, the first time it connects, it'll need to go to the catalog to figure out which database to redirect to. But then we have a caching layer for performance. And so any subsequent connections during that session, it will automatically connect directly to that tenant's database without having to go look up in the catalog. And so this is a great capability where you can focus on where you're making money with your application and utilize the functionality of the client library to help develop these applications easier. Let's check out the client library.
All right, and I'll use the same demo application again to illustrate this a little bit. And let me actually view the solution. So here is the demo solution, and if you look into the references, you can spot the client library. Here, it's this reference. It's a library that's available through NuGet, so you can very easily to acquire it and add it to your projects. And as Deborah mentioned, it gives you these two sets of capabilities. One is managing the membership in my data tier and managing the mappings of tenants to databases. And then the second aspect is this highly efficient data-dependent routing and connection brokering. What I do want to show you today is essentially the connection brokering aspect. Here I'm in the code essentially right at the place, the breakpoint essentially is at the place where I'm about to open a connection into one of the databases given a tenant ID, so processing a request that came in through my web tier that was tagged with a given tenant ID. And the API that we give you is essentially over the metadata that defines the layout of your data tier, we're giving you an open connection for key call, which takes the tenant ID as its input parameter, and that's probably the most important input parameter. And as a result of that call, you're getting a regular SQL connection that has already been opened for you and points into the database that holds the data for the tenant ID that was given as the first parameter of the call. And from that point on, it's just a regular ADO.NET SQL connection, so you can do whatever SQL allows you to to do with that connection within the confines of that tenant's database. And I'm using that then, as you can see here, to do SQL commands, do a SQL data adapter, and so on. So let's see, since we have some time, let's see whether we can actually wire this up with the running application. So here is my running cloud service in Azure. Here is the process. And this will take a little bit, so it essentially remote debugging into an Azure data center. And let's see what happened. Something strange happened. Let's try this again. This looks a little bit better. Yeah, now it's not picking up the breakpoint. I think it rebuilt in the previous step. So essentially what you would see happening is, as we are working here, you'll see us hit the breakpoint, and now the breakpoint is not live, unfortunately. But what would happen is essentially the connection object would be populated with different connections connected to different databases for different tenants that I pull. So if I go into a different place, like this one, we would get another hit on the breakpoint, but pick up a connection to a completely different database. Unfortunately, because I rebuilt, I think in the previous step, I would need to redeploy the whole project to pick up the correct symbols. So that's going to take some time, and I'm not going to do that right now. But that's essentially one of the key places where the library can help you avoid writing a whole bunch of boilerplate code. So if you had to do that yourself, you would end up implementing a bunch of APIs just to do the management for your data tier, which databases are part of the data tier, how are tenants mapped to different connection strings. And then for data-dependent routing, one key aspect that we spend a lot of time with is to make sure that this really performs well and that you're not for each and every connection request are hitting that metadata database, because then it's very, very easy to overload your metadata database with just these connection lookups. So the caching infrastructure that we've put in place is quite smart, and it increases availability for you, but it also obviously increases performance as it avoids these round trips.
You have something analogous for Entity Framework?
Something analogous for Entity Framework. This works fairly well with Entity Framework. So there is, in the code gallery, there is a project that actually uses the client library together with Entity Framework. There are certain parts in the library that are not that well supported through Entity Framework. For instance, there is a part that allows you also from an API perspective to run queries across all of the databases through a .NET API. That's the part that's not well supported through Entity Framework. But just managing your data tier and data-dependent routing, that works pretty well.
So going to our fifth and last pattern that we're, additional question.
Yes. Where should we be picking up the tenant ID?
Where the question is, where should we be picking up the tenant ID?
So what I've done in this particular case is essentially the tenant ID flows in as part of the request, and let me actually show you that. Sorry. So if you look into, hello. So if you look into the URLs up here, you see this is Dogwood Dojo as a prefix to the URL. This one is different, has a different prefix. This one has a different prefix. That URL flows through the HTTP context of the request, and I siphon it off the HTTP context. I parse it and essentially then do a hash over the prefix. And the hash of that little string, that's my tenant ID. So it's kind of fairly simplistic, fairly straightforward. The only risk that you're running there is that you get hash collisions that are unwanted. But other than that, it works pretty well. And if you hit a hash collision, I mean, you can protect in your application against that. Sorry.
And there's a large number of data types supported with the client library, as well as all the date time types. So depending on the type of application, whether you're doing like temporal sharding, et cetera, you can utilize the different support of each of those data types to figure out what's the best implementation for your application. So the fifth pattern and last pattern that we're going to go into is transactions across databases. This is now available in Azure SQL database, and we're super excited about it. And so looking at this similar pattern where an end user connects in, and because it's cached, they get redirected directly to their tenant database. And here, we want to do a transaction across multiple databases, and we want those changes to be committed together or not committed at all as part of the request. And so essentially here we've brought Elastic Transactions to Azure SQL Database to be able to do a distributed transaction without the need for MSDTC. And so you can run, a lot of common scenarios where transactions across multiple databases come into play are financial institutions where you want to do a debit credit. It could be orders, products, details where you're committing that order and you want to ensure that the quantity of the product goes down. In the SaaS application that Torsten's been demoing with today, here obviously you don't want to sell the same seat to multiple people. And so part of that committed transaction of buying that ticket, you would potentially want a distributed transaction which ensures that that available seat gets taken out of the available seat pool. Again, familiar development experience with .NET. Everything now is embedded there with .NET 4.6.1, which with the latest updates, I think land on all the machines. And there's just, another scenario that here we showed reference data that we propagated through across all of the databases. There could be common scenarios where maybe you have a products in a separate database and you want to do distributed transactions across those databases when you're committing them. So in summary, we've gone over a lot of the best practices and patterns to be able to develop rich SaaS applications that provide you infinite scale. Here with Elastic Pools, you can continue to add databases, be cost effective with isolation, and we've, with the Elastic Database features, brought with it to you capabilities. We went over Elastic Query that enables you to do that rich query across multiple databases with familiar BI tools. Elastic Jobs to be able to execute management operations over your databases. Elastic Transactions, now that you can do distributed transactions across multiple Azure SQL databases, and the client library to save you time in developing those applications. Torsten, you want to add some more there?
No, but don't forget Elastic Pools, essentially, as you mentioned, as the starting point to really help sharing resources across your data tier. And if you pull the slides, remember the different challenges, and once you get a hang of these challenges, it will take you to, hopefully, a good capability to help you to address those challenges when you're implementing applications like that. All right, with that, there are a few references. So if any of these topics or features or capabilities that we touched on is of interest to you, go pull the slides and follow the references here. This is essentially the list of the different Elastic Database capabilities that we spoke about today. Also, don't forget to submit your feedback. And if you have further questions, either stop by after the session or reach out to us via email, ddov@microsoft.com or torsteng@microsoft.com.
I did also want to mention we have put together a virtual Microsoft Virtual Academy learning series on the Elastic Database features that actually goes through every single one of these modules in nice about 7 to 15-minute videos. So if you need to go back and get a quick refresher and a deep dive just in that area, go ahead and just search Elastic Database for Azure SQL Database out on Microsoft Virtual Academy. I think we've got about 4 minutes for questions?
Yeah.
Okay.
Quick question about the high scalability and high performance. You know, we have SQL Server 2014 of the high the availability group. So I can have a multiple nodes. If I want to move it to the platform as service SQL Server database, do we have still a capability to say we want to read only and rewrite?
Yes, so the question is around with Azure SQL Database, do we still have that capability of distributing some of those read loads to other nodes? So with the geo functionality, you can have, I think it's now up to 10, I gotta double check, but there's a large number of secondaries, at least 4, that you can create, and those secondaries can be read secondaries, and you can redirect any read only queries to the secondaries and not put that load on your primary database.
So that is also available on that.
So that's also available with Azure SQL Database.
The other thing is for geo-redundance. Does it need to pay additional cost for geo-redundance across the multiple data center around Microsoft around the world?
So the question is around geo-redundance and with regard to the offerings and the cost. So yes, there is a cost to geo-replicate your database. We do have different offering levels that is the same across all of the tiers and elastic pools that enable you to choose kind of what is the response that I need from my application, and based on that response time from my application in a disaster scenario, what is the price point that I want to look at? And so there are a set of offerings there. We also have recently released the active geo-replication, which enables an immediate failover in the event of a disaster recovery, and that's also customizable. So you can decide, hey, instead of an ops team needing to go in and make the decision, hey, we're down, I want this critical application to automatically fail over.
Is it possible to have 2 different databases in the same pool if the databases are in different regions?
So the question is it possible to have 2 different databases in the same pool if the databases are different regions? So no, not at this time. Elastic pools are scoped to the server. So a server is scoped to a region. So if you have multiple regions where you're hosting your application, you could create multiple elastic pool, an elastic pool in each of those regions. But remember, with jobs and elastic query and distributed transactions, all of those capabilities, it's just a database connection. And so you could still, in your target member group, for example, add both of those pools and manage that application that spans across regions all together in one.
So you mentioned the recommendation engine for putting databases into pools. There's also a recommendation engine now for like performance indexes.
Yes.
Is that something that's also available in Elastic Pools? And if it is, what's the best way to use that? Do you literally just turn it on for like all 400? Or do you have like one and then deploy that with jobs, like the recommendations that comes out with?
Yeah, great question. So the recommendation engine for indexes, at this point in time, so it is available across all the databases, whether they reside in a pool or not in a pool. It would give you a recommendation, hey, here, you should look at this index. And not only that, we have a whole query data platform that does the analysis of the replaying the workload, the index being on and the index being off, and it actually also gives you information of the cost of the index and the benefit of the index. At this point in time, it does deploy that index to that individual database. We're working really closely with that team to make the hook seamless, such that, hey, I want to actually deploy this to all of my databases that share the same schema, and we want to integrate jobs directly in with that, so it's not a separate individual step to then go deploy that. So we're working really closely with that team right now.
You can also run it in kind of I feel lucky mode, where it basically creates all of the indexes automatically for you. So if you're feeling bold, just basically do a config deployment with a job across all of your databases, turning that capability on, and then it will just go on autopilot and create and drop indexes as it sees fit. You may or may not like it, so some folks want to have very tight control over the physical design that they roll out across their data tier, so that they know that they have the same set of indexes on all of the databases. You're likely not going to end up with the same set of indexes if you do that. So you have to be open-minded and accept very different physical designs on different databases in your data tier if you do that.
Especially if your tenants have different patterns, workload patterns.
Yeah. Any other questions? In the back, yes.
Can the Elastic Jobs target certain databases in the pool, or does it have to go across the entire?
Yes, so the question is, can Elastic Jobs target certain databases in the pool, or does it have to go across the whole pool? Fully customizable. So that target group could be individual databases. It can be the pool. It can actually be all databases in a server with the exclusion of a mapping database, for example, or a catalog database. So it has full inclusion and exclusion capabilities. And again, at my theater show tomorrow, I'll be showing off more of those capabilities. And the nice thing about those target groups is you can reuse them. So most likely people have multiple jobs that they need to run on different sets of databases. And so instead of having to recreate those target groups, you just create them once and then you can reuse them for a job over and over and over again. Hey, I really want to thank you guys for coming to our session today. Please don't forget the evals and follow up, and we'll be up here for a couple more minutes if you have any other questions. Don't hesitate to email us either. We'd love to hear from you.